Yeah, who cares? All right, write that down. There's your intro. Okay, so this, actually, yeah, union's right here. Good. Good find. I should pick a different, that is a U. U means union. Union means bring together. The word or goes and coincides with dealing with unions. And it actually means the probability of this or that happening. You add those two together to get the overall probability. And you'll see that coming up here. Whereas this symbol represents, intersection. You'll come to find out this actually corresponds to the word and, but we'll do some probabilities with that coming up shortly. Really, a word that you can put with intersection is what do they have in common? As you can see, I have struggles still writing and speaking, apparently. What do they have in common? Like A and B in this example. This next vocab word, mutually exclusive events, come from what's the probability of A or B occurring? You can put that down underneath this. This is what this corresponds to. What's the probability of A or B occurring? So, for instance, you roll a dice. What's the probability of getting a 1 or a 4? Well, you could figure that out pretty easily. It's 2 out of 6, right? That's 2 out of the 6 possibilities. Probability of getting a 1, though, is 1/6. The probability of getting a 4 is 1/6. You can do what with those probabilities to find the overall? Add them. That's what the word or means. Very simple. Now, 1 and 4 on a die are mutually exclusive. Put that Chromebook away, sir! Now let's talk about a deck of cards and kind of jump ahead of the scenario. What's the probability of drawing a king or a 7? 8 out of 52. There's 4 kings, there's 4 sevens. Now let's get crazy with it. What's the, right, we'll simplify that. Fine, that's right, great. Probability of getting, let's try to make this work out. A heart or a 7. What's wrong with that? Like, what do we have to figure out there? What goes on with that? And then actually, that's the next example. There's a 7 of hearts. By the way, how many hearts are there? Look at your cheat sheet. 13. So there's 13 hearts. How many 7s are there? 4. Okay, so 13 over 52, 4 over 52. The problem is, what did you count twice? The 7 of hearts. So therefore, you got to get that out or figure out that. So that's a not mutually exclusive event. There's an overlap. There's an intersection. There is a 7 of hearts or something that works in both things. So mutually exclusive events are like this. Okay, now get out your deck of cards or your little sheet if you don't know cards. But then also there's something added to this that my sheet I gave you doesn't quite show this. The other teacher, no, I don't think she did actually pass this out eventually because it was too large. But here's a deck of cards picture of that. She was going to give that. So you want to pass that around. Why or what is a face card? Those that know, what's a face card? King, Queen, Jack. Why? Because they all have what? Faces. There's a picture of a king, a queen, and a jack. My little sheet I gave you doesn't show those pictures. It just shows the suits and then how many of each card there is in each suit. So the way this could be written is, what's the probability? Let's go red. Probability of a face card. I'm just gonna put FC. Or union. A red 2. I don't know. Red 2. or getting a 7. You have to understand you're only drawing one card. They just want to know, when drawing that one card, what's the probability of getting this or this or this?
A red 2 and a red 7, or a red 2 and
Or a 7. I'm drawing only one card. What's the probability I get a face card or a red 2 or a 7? Very specific. Why is this mutually exclusive? Is a red 2 a face card? Is a red 2 a 7? Is a 7 a face card? No, these are all unique with no intersection. How many face cards are there? We already talked about that. 12. There's 3 for each suit. King, queen, jack of every suit. How many red 2s are there? 2. So there's a 2 out of 52 chance of getting a red 2. And then how many 7s are there? 4. So the probability of getting this or this or this, and actually you could have just looked at the sample space and counted. There's 12 face cards, there's 2 red 2s, there's 4 7s. Taking too long on this. I think divide by 2 and you end up with 9 out of 26. And then as always, you can change that into a decimal or a percent. It's dead. Oh boy, there's a picture of my kid. And by the way, like I said, if you were in Algebra 2, you did all this. This is a real simple day today. Just lining up some terms here. So the opposite of that, we already talked about. Non-mutually exclusive events. There's something in common between the listing that they have there. This is a formula you should remember, even though with the simple card questions, you could probably deal with it. Okay, whoa. And figure it out. But this is what this formula means for this simple little question. Find a probability of selecting a heart or a face card. That means you're still selecting only one card. When this gets to the chapter quiz or the next quiz, you really got to line that out. How many cards am I going to have when I'm done? You only get one. What's the probability that one card is either a heart or a face card? What's the problem with that? There's an overlap. So let's draw a heart. Probability of a heart or a face card. But in this case, we have to subtract out the intersection of a heart face card. How many heart face cards are there? 3. So when you see this in this formula format, actually I wrote this wrong. The probability of this, let's just coincide it with this, equals the probability of the heart. Let's call that piece of A. What's the probability of a heart? How many hearts are there? 13. Kind of wrote that not the way I wanted to. Plus, how many face cards are there? How many face cards are there? 12. But here's the problem. You counted heart face cards twice when there's only one set of heart face cards. So what you have to do is subtract out the intersection of that. There are 3 heart face cards, and then you'll have the appropriate amount of possibilities here. So again, I'm just trying to get you to understand what it means to be non-mutually exclusive. There's an overlap that needs to be considered. This is one way through the formula. 25, 22 out of 52, which is 11 out of 26. Feel free to make a decimal percent. Okay, that was just discussion. We discussed off to the side like months. We talked about what's the probability of selecting a month that ends in Y. We've said there was 4 months that end in Y, 4 out of 12. What's the probability of selecting a month that has 31 days in it? We talked about that being 7 months, 7 out of 12. What's the probability of selecting a month that ends in Y or has 31 days in it? Not mutually exclusive. What months had a Y in it that had 31 days again? May, January, and July. So there's the overlap between the 2 other probabilities. Not a mutually exclusive statement. So therefore, to find a probability of this or that, you'd have to subtract out the repeats. Okay, now, this is just this is like a terminology. You mark that. Put a big star around that. Circle that. You have to understand that that line over A means not A. What's the probability of not A occurring? Okay, so that's called a complement, or really what you should say is the opposite of something. We actually did this yesterday. I said this all day long, and everyone just looked at me and drooled, I think. I don't know. Remember that question about the 36 possible dice rolls with 2 dice, right? And the last question of the day was the probability of at least a sum of 4. And I said sometimes it's nice to think about the opposite of that, and then it's 1 minus that possibility. So the sums of less than 4, weren't they 1 and 2 and 2 and 1 and 1 and 1? So there's only 3 out of 36 that were not at least 4. That means 33 out of 36 is at least 4 or more. That was the complement. We talked about that yesterday. So these can be interchanged, of course. Yesterday we did the probability of A happening equals 1 minus the opposite of the probability of A happening. The probability of the opposite of A happening, I should say. Why 1? What's 1 represent? 100%. 100% chance. So these little lines over here, what's the probability of not getting a red 2? It's 1 minus the probability of getting a 2. That's red. How many 2 red 2s are there? 2 red 2s. A lot of 2s going on here. So this is 50 out of 52, which is 25 out of 26. You can approach things this way. Sometimes in very large problems, you might want to do that. And that will be done frequently throughout this chapter. Okay? Rolling a die. Isn't die plural? Rolling a what? Roll 2 dice. Roll 1 die. Did I do that wrong yesterday? Well, why did anyone say anything? Oh, did you? Okay. What's probably I probably would have thrown a fit, right? Not 6. You already got this done. 2 dice, 1 die. I even did a 5th hour, so I may have screwed them up too. Don't you dare write this next one. How stupid that is. Sorry, I don't want to. It's not stupid, but it's obvious, right? Right? Okay. All right. So I like this. I pulled this out just because it kind of I can write on this and get everything down together because I want you to make sure you understand these terms. Don't worry, we're almost done. If you're annoyed right now, don't worry. We're almost there. Okay, now, so here's S. What's S stand for? Sample space. Sample space. So, no, that'd be nice. All right. So the sample space is 1, 2, 3, 4, 15 events occurring. Within this sample space, there's some events. Event A, event B, event C, and then these aren't in any events. Okay, so first of all, what's the probability of the sample space? That means what's the probability of those 15 things happen? 15 out of 15, 100%. What's the probability of not anything happening? 0. That's null set. Okay, so what's the probability of A? Very simple. Probability of A is 1, 2, 3, 4, 5. 5 out of 15. What's probability of B? 1, 2, 3, 4, 5, 6 out of 15. Reduce. Now what I'm going to go to right now is what's the probability of A union B? Well, from this drawing, is A and B mutually exclusive? Yes or no? No, they have what's called an overlap, which is denoted by this symbolism. So the overlap is they have 2 things in common. So if I were to do this through the formula, the union of A and B would be their probabilities, 5 over 15, 6 over 15, minus the overlap. That's where you get the 9 possible. Or you can just look at this. When you put A and B together, you count 9 dots. And that's what would have happened if you just looked at my card sheet doing the card question. And just counting how many things happen that are a heart and a face card. Okay, so blah, blah, blah. I just kind of liked it. I don't know. A union C, is AUC mutually exclusive, yes or no? AUC mutually exclusive, yes or no? Yes. They have no intersection. That's why you would just go ahead and add those probabilities. And then what's that line over C again mean? Everything but C. So not C. Okay, so to end this off, because someone's so tired, I knocked them out. Here's some probabilities of properties of probability. All right, for any event, y from 0 to 1. Either none of it could happen, or what's the 1 stand for? All of it, which is what percent? 100. That really is everything we just said, just in a nutshell. Done. Done. Done.